Welcome. We're going to talk about right triangles and the Pythagorean theorem. Our objectives for this video are to be able to identify the parts of a right triangle, use the Pythagorean theorem to solve for the missing side lengths of a right triangle, and use the Pythagorean theorem to determine if a triangle is a right triangle. If not, it's a wrong triangle. Okay, little joke there. So first let's look at triangle parts. Okay, here's my right triangle. I see that because I've noted there's a right angle there. First, side A, we'll just call it A, is the leg. Side B is also a leg. So much like an isosceles triangle, the sides have special names. And in a right triangle, the longest side is the hypotenuse. So the longest side is the hypotenuse. The two shorter sides are both called legs. Now the Pythagorean theorem states if a triangle is a right triangle, then the sum of the squares of the two shorter sides will equal the square of the longer side. The sum of the squares of the two legs will equal the square of the hypotenuse. And this is a common visual representation of what the Pythagorean theorem is stating. So I have a right triangle here, noted by the right angle there. And if I create a square with side lengths of A, and here I assign them the number 3, you can see that there are 9 units inside. So A is 3 squared. It's a 3 by 3 grid. B is a 4 by 4 grid. And C is a 5 by 5 grid. Imagine if we were tiling 3 rooms in a house, and each tile was exactly 12 inch by 12 inch. Well, I'm going to have 9 tiles in room A. I'm going to have 16 tiles in room B. And in room C, I'm going to have 25 tiles. If I add the number of tiles in room A to the number of tiles in room B, I'll get 25. Well, that equals the amount of tiles in room C, 25. This is a simplified version of how the Pythagorean theorem works. Now, this theorem also has a converse. If the sum of the squares of the two shorter sides of a triangle equal the square of the longer side, then that triangle is a right triangle. And so here I have a right triangle. It's a 3 for one leg, 4 for the other leg, and 5 for the long side. I can't call it a hypotenuse because I don't know if it is a right triangle or not. Well, let's take the two shorter sides and square them, and then add them together. They should, but we don't know yet, equal the square of the longer side. 3 squared is 9, 4 squared is 16, I add those together. 5 squared is 25. This should look familiar from the last slide. 9 plus 16 is 25. That does equal 25. Therefore, this triangle is a right triangle. And so the sum of the squares of the two legs equal the square of the hypotenuse. Now we're going to use the Pythagorean theorem to solve for a missing side. Let's go here. My pages are out of order. Oh well. So we're looking for C. Find C. Well, I have A and I have B. I'm looking for C. So remember the Pythagorean theorem is A squared plus B squared equals C squared. The sum of the squares of the two legs equals the square of the longest side. 5 squared is 25. 9 squared is 81. That equals C squared. 25 plus 81 is 106. That equals C squared. I take the square root of both sides. I get the square root of 106 equals C. We can use a calculator to round that. We could simplify it, but we'll leave it there for now. Now, if I have the hypotenuse given to me, they're saying find x. Well, in my Pythagorean theorem, x is one of these sides. Let's say it's side A. So I'm going to have x squared plus 8 squared, because this will be side B, equals 13 squared. Well, x squared plus 64, which is 8 squared, equals 169, which is 13 squared. I'm going to subtract 64 from each side. I get x squared equals, that is 105. I take the square root of both sides. I get x equals the square root of 105. That's my final answer. So this side is the square root of 105. Now, we're going to use the Pythagorean theorem to find out if this triangle is a right triangle. We don't know. So, remember, we have a squared plus b squared equals c squared. I'm going to replace a, b, and c with the values of the triangle. I will say a is my shortest side, b is the next size up. It's the number that's in between the shortest side and the longest side. And that's going to equal, c will be 13 because that's the longest side. It's the largest number. I square these numbers, I get 25 plus 144 equals 169. If I add 25 and 144, I get 169. Yes, that checks out. This is a right triangle. Boom, good to go. Now, in review, right triangles and the Pythagorean theorem. We identified the parts of a right triangle. The two legs are the two shorter sides, and the hypotenuse is the longest side. It is the side opposite the 90-degree angle. We use the Pythagorean theorem to solve for the missing side lengths of a right triangle, whether we're looking for the side length that's a leg, or we're looking for the side length that's the hypotenuse. And then we use the Pythagorean theorem to determine if a triangle is a right triangle. We have a triangle with 3 side lengths given to us. We put those lengths into the Pythagorean theorem, solve, and if both sides of the equation are equal, then yes, we do have a right triangle.